Hello everyone. So in this video we will discuss about the selection sort algorithm. We will first understand what is selection sort and we will see a small demonstration of selection sort algorithm. So here as we are performing selection sort, we are basically sorting the elements of an array into ascending order. So let's say we are given with this array with 5 elements as 3, 1, 5, 2, 6. We know these elements are unsorted and we want to sort them in ascending order using selection sort algorithm. So in this algorithm what we do is, we first divide this array into two parts. One is the sorted part and other is the unsorted part. So here you can see at the start all the elements are unsorted. So our sorted part and unsorted part looks like this, that all the elements currently are unsorted and there are no elements in the sorted part. Now what we do inside this algorithm is, let's say we are given with this boundary. What we do is we start with this boundary and we find which is the minimum element among these all the elements in the unsorted part. So once we find out which is the minimum element among these elements, we simply swap it with the leftmost element of this boundary. And as soon as we swap them, we know that the minimum element which we found is at its correct position. So for example, here you can see, when we pick the minimum element and swap it with the leftmost element of the unsorted part, which is this boundary, after swap, the element now becomes part of the sorted array. So for example, among these 5 elements, if we find out which is the minimum element, we can find that 1 is the minimum element. So what we do is, we see which is the leftmost element, which is 3 here, and we simply swap these two values. So it would look something like this, that these elements are swapped, and we also know that as 1 was the minimum element among these all the elements, 1 is at its correct position if we actually sort this array completely. It simply signifies that now 1 is the part of the sorted array and these 4 elements are part of the unsorted array. So this finding of minimum element in the unsorted part and swapping it with the leftmost element of the unsorted part is repeated till all the elements are part of the sorted array and there are no elements left in the unsorted part. So the idea behind this algorithm is very simple. We divide the array into two parts, sorted part and unsorted part. From the unsorted part, we pick the minimum element and we swap it with the leftmost element of the unsorted part. So the element which is next to this boundary, we simply swap the minimum element with this. And after we perform this swap, we know that the minimum element which we figured from this array is at its correct position. So at the each pass, one element from the unsorted part becomes the element of the sorted part, and at the last we only get the sorted part. So let's see the demonstration of this algorithm with a small example. So let's suppose we are given with this array having 6 elements indexed from 0 to 5 and they are unsorted. So let's say if we want to sort them in ascending order, here length of this array is 6. So the first step we do is we divide this array into two parts, sorted and unsorted part. So initially all the elements are unsorted. So therefore the sorted part has no elements and the unsorted part has all the elements. Now let's see what happens when we perform the first pass. So here what we do is we simply start from the unsorted part and we find that there is one element 3. So let's say we are assuming that 3 is the minimum element of this complete array. Now what we do is we go to its next element and we compare 3 with 1. and we check that whether 1 is less than 3 or not. So here 1 is less than 3. So which means that our assumption is wrong and 1 will become our new minimum. So 1 becomes our new minimum, and simply we go on like this. We check whether 5 is less than minimum. So 5 is not less than minimum. We move ahead. We check whether 2 is less than minimum. So 2 is not less than 1. So we move ahead. And 4 is also not less than 1. 6 is also not less than 1. So here you can see, after we completed the first pass, we found that 1 is the minimum element among these all the elements. So now what we do is, we simply swap this 1 with the leftmost element of the unsorted part. So the element next to this boundary, we simply swap it with that. So here we'll simply swap 3 and 1. So 1 comes here and 3 comes here. And after first pass, 1 is at its correct position. So therefore, now our sorted part has one element and unsorted part has the rest of the elements. Now we'll simply do the second pass and we perform the same steps. At first we consider 3 is the minimum element. We compare it with each and every element next to it. So 5 is not less than 3. We move ahead. So here 2 is less than 3. So 2 will become our new minimum. We move ahead. 6 is not less than 2. And 4 is also not less than 2. So after second pass, we found that 2 is the minimum element among the unsorted part. Now after we found out that 2 is the minimum element, what we do is we simply swap it with the leftmost element of the unsorted part. So we'll simply swap it with 3. So 2 comes here and 3 goes here. And we also know that 2 is at its correct position now. So therefore, now our sorted part has 2 elements and unsorted part has rest of the elements. So we'll go with the third pass now. We assume 5 is the minimum element and we compare it with the rest of the elements. We check whether 3 is less than 5. So yes, 3 is less than 5. So therefore 3 will become our new minimum. We compare whether 6 is less than 3. So it is not. So we move ahead. We check whether 4 is less than 3. So 4 is not less than 3. So after the third pass, we came to know that 3 is the minimum element among these elements which are part of the unsorted array. So after finding this minimum element, we simply swap it with the leftmost element of the unsorted part. So leftmost element is the 5. So we'll simply swap 3 with 5. And now our sorted part has 3 elements and unsorted part has the rest of the elements. We'll continue with the fourth pass. We'll assume 5 is the minimum element among the elements in the unsorted part. We compare it with the rest of the elements. 6 is not less than 5. So we move ahead. 4 is less than 5. So 4 will become our new minimum. So after this pass, among these 3 elements in the unsorted part, we came to know that 4 is the minimum element and we will simply swap it with the leftmost element of the unsorted part. So we'll simply swap 5 and 4. Now our sorted part has 4 elements and unsorted part has rest of the elements. So our fifth pass will start. We assume 6 is the minimum element and we compare it with the rest of the elements. So there is only one element which is 5. So we check whether 5 is less than 6. So yes, 5 is less than 6. So 5 will become our new minimum. And after the fifth pass, we found that among these two elements, 5 was the minimum. So we'll simply swap 5 with the leftmost element of the unsorted part. So 5 will come at this place and 6 will go at this place after the swap. And once we perform the swap, the minimum element which we swapped becomes part of the sorted array. So friends, here you can see that after the fifth pass, 5 came to its correct position and we are left only with one element. So by default this element at its correct position. So we don't have to perform these steps on the last element because it is already at its correct position. So the only thing to consider here is if the length of array is 6, then there are at least 5 passes, which is n-1, which is the length minus 1. So if there are 6 elements, we have to perform 5 passes to get the array in sorted form. So this was the basic idea behind the selection sort algorithm. We usually do 3 steps. First, we divide the array into 2 parts, sorted and unsorted. At the start, all the elements are in unsorted part. And then we apply the selection sort in different passes. So with each pass, what we do is we simply find the minimum element of the unsorted part and simply swap it with the leftmost element of the unsorted part. And after this swap, the minimum element which we just found becomes part of the sorted array. And this process is repeated till all the elements are part of the sorted array. So friend, this was the basic demonstration of the selection sort algorithm. In our next video, we will see the complete animation of the selection sort algorithm step by step. I hope you have liked this video. And in case you have liked this video, then please like, comment, share and subscribe my channel. Thanks, have a nice day.